Hi, so this evening I was working on a friend's Microbee where he's had some issues getting his refurbished keys back in, and I decided to do a couple of experiments on one of my old Microbees. I found 4 altogether. I've got the new Premium Plus that came out a couple of years ago as a completely new kit from Microbee down in Melbourne, and I've also got a couple of Rombees, well 3 altogether. This one's a 32K one. It's also got the WordBee word processor in it. Most of the keys were dead on it. The reset key still works. The P, these brackets were okay. None of these other keys work. And on the Microbee, if you hold down the reset key and the escape key at the same time, it'll do a cold boot into BASIC. So that wasn't working on this one. So if I just pop the covers off. And Microbees are notorious for having had really atrocious key switches in them from when they came out in about 1982 or so. So you can see the core board on this one is an MB1732. It's got WordBee on it and has the basic ROM etc on it, and then 32K altogether. These are 2K by 8 RAMs, and then you've got the motherboard. So let me just pop that core board off. Okay, so I popped that core board off, and you can now see the motherboard. Over here we have the Z80A processor, which on these runs at 3.375 megs. It's a 13.5 meg crystal divided down. The SY6545, which is the video chip that also takes care of the keyboard scanning. And you can see a Z80A PIO. A very basic machine. Those 2 edge connectors are for the core board. And the core board used to determine the personality of the Microbee. You could essentially take this ROM-based one out and insert the one of the RAM, either the 56K or later the 128K and modified versions with 256 and more K of RAM core boards. They had a floppy disk controller on them. So anyway, what I've discovered with these keys is that if I use a little bit of silver conductive paint, which I bought on eBay, it's this stuff, and I use that to paint the contact, which is a little carbon rubber style contact in the key switch. It seems to work. So I did that on the escape key and it's come good. So I'll show you what I did on another key as I remove it. So this is the back of the motherboard. You can see here the keyboard matrix. And that goes up to, I think you can possibly see it. No, you can't on this side. It's near the video controller. There's a 74LS 151 and a 156. It's a MUX and a DMUX. And they go back into the video controller. I think they use the light pin input. I can't remember exactly. I need to double check it. So what I'm going to do is unsolder another one of these switches and pop it off the board. I'm going to use a vacuum desoldering gun, but I can't hold the camera and the soldering gun, so I'll have to come back to you. You can see the vacuum desoldering gun has done a nice job of removing the solder from around those contacts. On these older boards you always got to be really careful not to lift the pads. They're overheating. If you're not getting anywhere when you're desoldering it, just stop. Don't just sit there with the iron constantly on it, otherwise you will damage it. So it's often a bit of a struggle, but you can see that I got it out quite cleanly. You just need to be careful that you don't rip those pads off the top, otherwise you're going to have to jumper a whole lot of things on the other side. So that's what the key switch looks like. A plunger, and by pushing these tabs in, or actually pushing that out on one side, we can flip that whole bottom bit out, so I'll show you that. Okay, so here I've pushed that out. You can see those little tabs have come out, and as I pull it right out, there we go. And it consists of the gold plated terminals there, a little spring, and this plunger assembly, and that little carbonized bit of rubber. That's what causes all the drama, and has done since the day they came out of the factory. It basically just loses its low resistance properties, and everything stops working. So what I'm going to do is paint that with a bit of that silver conductive glue or paint, and see what happens. So here under the microscope you can see that I've put, apart from making a mess and slopping stuff everywhere, I've put a fair coat on that little rubber pad, which was the carbonised rubber, the conductive rubber. So we're going to hit that with some heat just to speed up the drying process. Put the switch back together and we'll measure the resistance. This switch was completely open circuit, even with the plunger pushed down before. So there's a shot just before I put the cover back on. You can see the conductive paint on that pad, and because I've put a reasonably thick layer, it should probably last quite a while, but time will tell. So if you try this, if you've got completely dead switches, you've got nothing to lose, I guess, because they may work for long enough to be able to have some fun with it and demo it, once every 6 months or something. But no idea. So I'll put it back together and hit it with a multimeter, see what it does, and then put the machine back together and hopefully show you the button working. Right, so this is where it gets really tricky, holding the phone at the same time. This is the multimeter on continuity mode, which of course won't show us the real resistance. But when I push down, you can see it definitely works. Now if I try and flick the multimeter to ohms, and of course drop the lead, so hang on a second, right, let's try that again. So that 1 meg that you can see is just the resistance of my fingers on there. If I now push the plunger down, and we go down to 0.7 ohms. Now these switches, even when they're working well, are somewhere between 0 and 50 ohms. To have 0.7 ohms resistance, or 1 point something ohms, whatever, is just unheard of. So let's see how that goes. Righto, so I've booted up the Bee. I'm running it on this really small monitor. You can see it's just sitting there. Now, if I press the number 3, nothing happens. Number 2, there's number 1. Working like an absolute charm. So, I reckon I'd call that a bit of a win. So I don't know if I'll have the energy to do the whole keyboard, but it's promising. And I could well end up with 4 working Bees instead of just the one good one that I've got. Cheers.